All right, hello everybody and welcome back to the geometry. We have a couple new theorems to go through today with a couple examples to go with them. And so we'll go through the theorems first and prove them, and then we'll follow that up with a couple of the examples to help with that theorem. Okay, so the first theorem is the angle bisector theorem. And it reads, if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So you see my drawing there, and you see angle APB. And you're given that point C is on the bisector ray PC. So you see that PC is a bisector, cuts that angle to two congruent angles, and point C is on that bisector. We have to prove that point C is equidistant from the sides of that angle, ray, which are ray PA and ray PB. In other words, we got to prove down here that segment AC is congruent to segment BC, because remember the distance from a point to a line is the length of the perpendicular segment. So AC represents the distance from point C to that side of the angle. And the distance BC represents the distance from point C to that side, the other side of the angle. So if we prove those two segments are congruent, AC and BC, then we will have proven that point C is equidistant from the sides of the angle. So we're going to do that by proving those two triangles congruent. So first of all, we know that ray PC is a bisector, so we got already an angle in each triangle. We know that PC is congruent to itself by reflexive property. And now we can say that the two triangles are congruent if you can see that there by angle, angle, side. Angle, angle, side. Angle, angle, not included side. So the two triangles are congruent to each other by angle, angle, side. And so now we know all their parts are congruent. So now we know that AC right here has got to be congruent to BC by CPCTC. So remember, that stands for corresponding parts of congruent triangles are congruent. So we proved then that point C, since we knew it was on the bisector of the angle, we just proved that it was equidistant from the sides of the angle. And we'll go through a problem with that in a bit. Okay, now we're going to give the exact converse of that angle bisector theorem. So here's the converse. If a point is equidistant from the sides of an angle, then it lies on the bisector of the angle. So if you look at the given there, point C is given to be equidistant from one side of the angle PA and the other side of the angle PB. So I've got that marked off here. So AC and BC are going to both be congruent because that point C is the same distance from one side of the angle as it is to the other. So that's marked off here. So again, we're going to prove those two triangles congruent, and then you'll see what happens from there. So we know PC is congruent to itself by reflexive property. Now we know that those two triangles are actually congruent by HL, right? Because they're both right triangles, and they both have a leg congruent, and they both have a hypotenuse congruent. So that's HL. Now, because those two angles are congruent, we know all their corresponding parts are congruent. So now we know that this angle, APC, is congruent to this angle, BPC. Again, by that reason, corresponding parts of congruent triangles are congruent. Okay, and because we know those two angles are congruent, we now know that PC is a bisector of angle APC. So basically, we prove now that point C lies on the bisector. That line is a bisector. We proved it. So we proved the conclusion of the theorem that point, which is equidistant from the sides of the angle, lies on the bisector of that angle. So there's the converse. Okay, so now the problems that go with these two theorems are actually pretty simple. So my challenge to you is not just to get a number, but to actually understand why the theorem applies to the problem. Okay, let's look at this first example. So we see point M is on the bisector of angle JKL, and we're looking for segment LM there. So we have a theorem that fits this perfectly, and that is if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So that means that JM is going to have to be equal to LM, right? Because that point M, which lies on the bisector of angle JKL, must be equidistant from the sides of that angle. So that means that that LM is the same, 12.8. Okay, so we can replace that with 12.8. All right, that's all there is to it. So again, there's nothing to calculate, but the most important thing is, do you know how the theorem applies to that problem? All right, let's do one more example using one of our new theorems. Okay, so in this example, you're trying to find the measure of angle ABD. So you're trying to find the measure of this angle right here. Okay, now one thing we are given is that down here, ABC is 112. So that's this angle. That's the bigger angle here, ABC. Okay. Now, what we know from that diagram is that point D is equidistant from the sides of the blue angle ABC. How do we know point D is equidistant from the sides? Because its perpendicular distance to those two sides is both 74. 74 to one side and 74 to the other side. So we've met the condition that a point is equidistant from the sides of an angle. Now let's make sure the theorem fits and understand what the results are. So the theorem that fits is, if a point is equidistant from the sides of an angle, then it lies on the bisector of the angle. So point D, because it is equidistant from the sides of angle ABC, lies on that bisector of the angle. So that tells you that BD is a bisector. It tells you that ray BD, oops, that's a B there, ray BD bisects angle ABC, because point D is equidistant from the sides. So D must be on the bisector of the angle. Okay, so that means that this angle and this angle must be congruent, because ray BD is a bisector. So to find the measure of angle ABD, which is what they were asking, that's just going to be 112 divided by 2. Because 56 degrees. So there you have it. We found what they wanted using one of our new theorems. Okay, to summarize, we've had two new theorems, and we have to know them literally forward and backwards, because that's what they are. They're converses of each other. The first theorem is the angle bisector theorem. And it says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. And the other new theorem is the converse of the angle bisector theorem, and it says if a point is equidistant from the sides of an angle, then it lies on the bisector of that angle. Okay, so there you have it. Let's take the information we have now and try our luck at the assignment which is posted. And so enjoy. Good luck.